Good morning. I've got my coffee. Just a quick one to just dump my brain. I've been doing this video call informally with some people, but in the effort of not repeating myself, let's just get it recorded. Okay, so today I want to go into quickly some build systems. So there were some people about a year ago I ran into, and they're doing some really cool stuff with monorepos, and they brought me into the fold and helped me out. Everything I'm about to show you here is based upon their ideas and intellectual property, but it's all available under MIT. It's all open source. You can do it yourself. So let's dig in. All my software is in a monorepo, all of it. And there's a particular reason for it, because there's a Unix philosophy about how things should be done. Everything in Unix should be built from source. Unfortunately, the industry is not like this. The industry, unfortunately, has gone down this path of supplying Docker files, or Docker images, or Debian devs, or RPMs, and that's like the wrong approach, because what that's doing is pre-compiling the artifacts before the consumer, which means it's impossible to specialize the artifact. This is a huge problem. Like, it's created an entire cottage industry of security products that analyze everything in your software stack to see if you're compliant, if you've got a vulnerable version of OpenSSL. But what I'm about to get into is that entire cottage industry would not typically be needed. It's still important, but it wouldn't really be needed if you approach things from a different point of view. You still need audits and security checks, but like this scanning of dependency stuff, it really comes down to the reason it exists is we don't have single sources of truth. And we don't have single sources of truth because we've got bad build systems. Anyway, let's get into it. Cool. All right, so my monorepo is on GitHub. Go forward and fork it. If you want the MIT stuff, head to code.tvl.fyi. This is the upstream. And this contains everything I'm about to show you. It's really cool. Hopefully, this is going to be a little bit more accessible than that. Okay, so first up first, let's open my developer environment. I do everything in Gitpod. I don't have dev tools on my local computer. So that's going to build up my environment that was built with continuous integration. And as it boots up, let's go across and have a look at the internals of this thing. All right, so there's a couple of things I'm going to show you, and that is in particular this bin directory. Now, this bin directory, if you notice it, there are a whole bunch of symbolic links. These are all symbolic links. So my environment is essentially a Docker file, but that Docker file doesn't contain any binaries. Typically, the way that you would normally do a Docker file is you do apt-get install, and you install Pulumi or install the Vim, and you do sudo apt-get install, and you install the binaries in the what's called the FHS. So the Linux, so the file system hierarchy standard. So that's like /opt. If you ever seen /opt, /etc, /dev, and all that stuff, the reason you have to use sudo is to allow you to be able to install into the file system hierarchy standard. It requires elevated privileges. What I'm about to show you is I don't use that at all. No sudo is used, none of that. It's all compiled from source. It's all lazily evaluated, including installation of the binaries. So what that looks like is all these binaries I would normally use in my environment are essentially symbolic links. They're a symbolic link to a dispatch script. So all these are like symlinks to a dispatch script. What the heck is going on there? So let's look at the dispatch script. So if you're coming from a Google environment, you're an ex-Googler, you probably recognize some of these conventions. So the idea of third party. What's happening here is everything needs to be vendored. And we'll get into the vendoring for a sec. So what happens is, if we've got Pulumi, for example, what's actually happening is I just do a case statement, and then it tells the build system to evaluate the expression for Pulumi, and that's how I get my binaries. That's how I get my binaries for Pulumi, and whilst I don't need to do it on this site in this way, but because I'm not using the Unix file system hierarchy standard, I can side-by-side install 4 or 5 different versions of Pulumi. I could expose out a Pulumi v1, Pulumi v2, Pulumi v3 for each of the different versions. This comes in handy sometimes, for example, in Terraform. There's rifts when you can't update. You can't update your version of Terraform because of the plugin dependencies, but you need to because other plugin dependencies, because it's a big ecosystem. So in that case, I would just expose out a Terraform -1 and then a Terraform -2, and then I can figure out the expression. So what is an expression? Right? Cool, that's booting up. So my repo is massive, absolutely massive. And what I want to show is this third party, this vendoring. Everything in this repository is vendored. Everything is built from source. So that expression, the expression that we showed before, say Pulumi, is right here. So this is essentially I'm re-exporting out Pulumi, and the question is where am I exporting out Pulumi from? Well, I'm exporting Pulumi out from my Nix packages. So this is where the definition, this is the single source of truth. No matter in my source control, I only have one version of Pulumi unless I so decide to have a different version of Pulumi. This will make sense very soon, why a single version makes sense. I'll give you an example. Instead of it being Pulumi, what happens if that was OpenSSL? Right? If all your dependencies if all your consumers' dependencies take a dependency on a single version of OpenSSL or a single version of Pulumi, and there's a problem in the supply chain, it's very easy just to update that one version of OpenSSL or Pulumi, and then it causes all the transitory dependencies to rebuild. Thus, you don't have the problem of is this version installed? Is this in our ecosystem anymore? It's super cool. All right, so my developer environment is set up. So I'm going to show you what this all means. First, you see a couple of things happening here. The environment's set up. I'm running VS Code in the browser, and you see here, what this is doing is actually, instead of doing sudo apt-get install, what it's doing is installing in my dependencies using the Nix package manager. And I want to show you something really quick. So I can type Pulumi. Pulumi doesn't exist. As soon as I initialize my developer environment, it configures all my pre-hooks and everything I want. If I type Pulumi for the first time, it's actually going to install Pulumi. And Pulumi is now available to me. Because I'm vendoring everything is pinned to a particular version. So let's show, right now I'm vendoring using Git submodules, which aren't great. I wish something exists better in the ecosystem. But what I do is I take a pinned Nix packages to a particular reference, and I have automation in the monorepo using GitHub Actions called Dependabot. And Dependabot right here, Git submodule, line 40. Once a day, it raises me pull requests to move forward the PIDs. Okay, so as soon as I merge that pull request, it's going to move forward everything, which is lovely. But even before that, let's say a pull request arrives to move forward the pin of my vended software, so Nix packages. What that would look like is a pull request would land, and it would update this reference. And it would update this reference right there. And because I have dependencies defined, if I go to third party, and if I go to here, and I go to Pulumi, by updating that pin in the pull request, essentially it's going to cause all these expressions to be reevaluated. And that's going to force them to redo recompilation of everything. And everything in this case includes the high-level applications in the repository, like web servers, etc., all the way down to low-level stuff like Pulumi and all the dependencies below that. So that could be like Terraform, or it could be curl, or it could be libsssl. Right? It's all there. So a single pull request causes the entire tree to get rebuilt and revalidated against acceptance tests, which is cool. So I will know very early every day if anything in my operating system, any operating system updates is broken any of my applications. And so a new version of OpenSSL comes out, all my applications are rebuilt against that OpenSSL update, which is done automatically by the pin. Anyway, getting a little bit off topic, it's still cool. All right, so how does this work? Next chapter. So if I go out of here, there's no Pulumi. If I initialize, if I can spell Nix shell, which is not mid copy. Now we got Pulumi again. Now, again, for those, just to recap and circle around, Pulumi, if I go to the bin directory, it's actually a symbolic link. Symbolic link is a link to the expression, that causes the evaluation of the expression. The expression is evaluate third-party /Pulumi. So it's all pinned. The pin's controlled and updated automatically by Dependabot. I have CI/CD built in, which causes the entire operating system and all the dependencies that take dependencies of the operating system dependencies to get rebuilt and revalidated on every pull request. All right, so this is where it gets cool. This just gets really cool. One of the philosophies in Unix is everything should be built from source. Everything. You should delay compilation to the consumer. You should delay specialization. The industry has not done this. It's gone away from this Unix principle, and it's actually hurt the industry greatly. So let's have a look at this. Let's say we're not talking about Pulumi. Right? Let's say that we're saying that a security vulnerability has been found in Vim, for example. Silly example. So let's explore my dependencies. So this is my third party. Let's find the definition for the application of Vim. So here I go into editors, and I go into Vim. Cool. So this is the source of truth. Everything in Nix is built from source. But if I was to run Vim now, what's going to happen is Vim's not in my Docker image, but it's going to evaluate this expression I've got. But Vim is, with Nix, it has source and binary substitutability built in, meaning it's going to evaluate the expression. And because the expression is not different to the upstream from my pin, it's going to download the precompiled version. Like this is all cache, this is all precompiled. So this is why it's coming from cache.nixos.os.org. You can run your own caches internally. I run my own caches for all my stuff. That means if someone's reviewing a pull request of my monorepo, they don't need to wait to recompile a C++ application. All that cache is precompiled, so they can just jump straight in and reproduce what I've got without having to wait for the compile. Insert XKCD comment right here. Anyway, so I've got Vim. Vim's under version control. You can see here that it was coming down from the cache. The reason it was coming from the cache is because the expression has not been updated. So the expression is essentially defining the source control. So here, if I wanted to switch out to a different version of Vim, because let's say there's a bug in it, there's a couple approaches. I could either update this here and push it to a different Git ref, a different branch, or I could just do the Unix philosophy of creating a brand new patch file, .patch, right? And then I just modify the build step, which is just here, right? The config flags or the build step to apply the patch file, and then done. So let's say that it was a security vulnerability in Vim. The patch file exists, but right now there's a mad rush in your organization because the patch file hasn't been applied, or it hasn't been applied in all your dependencies. I'm going to show you that's not a problem here in this ecosystem and with these type of approach. Normally, you'd be putting pressure on vendors to install the patch file. You're putting pressure on everyone to, like the ecosystem, like Ubuntu, to apply the patch file, generate the deb, and all the rest. What happens is you're helpless. There's a 0-day vulnerability in OpenSSL or Vim in this case, and you're screwed. You can't secure your infrastructure or your supply chain because you're waiting on third-party people that you do not pay, you do not control. They are unpaid, unsecured vendors. Your supply chain is under risk of attack. Now, the reason that is such a risk is because the industry precompiles binaries. If we got back to the Unix philosophy of everything should be built from source, you could do this. All right, let's just say that the vulnerability was in the NLS compilation module for whatever reason, okay? Right now, Vim exists, it works, it's instant. And let's say I just want to hack on this and just figure out if I fix the security issue. All you do is just remove the line and run Vim, and it's going to evaluate the expression, and it's going to go, hey, wait a sec, something's different here. The expression is now dirty. I'm going to download everything from here, and I'm going to recompile Vim. That's simple. Unix patch file philosophy. We've gone away from this. The industry's gone away from it. It doesn't make sense. Because now you can do this, it means that you can hack anything from not just in your application, your web stack, all the way down to, let's say you're doing development in the .NET stack, and you're in the core language team. You take a dependency on libunwind. This allows you, I can go in here and find I could find lib unwind, and I could make wherever the expression is. Actually, wherever the expression is, I can make a change to lib unwind, and the change to lib unwind would cause the entire operating system dependency tree to reevaluate and recompile, but also my application as well. There's none of this forking stuff. There's none of this crap. It's just back to Unix patch files. So this is compiling my special version of Vim, and this is a once-off thing. Once this compilation is done, what's going to happen is this expression is now going to be a cache hit. It's not going to be published publicly, but I can publish this publicly. The way you do that is a service called Cachix. So this is Cachix, and a lot of open source projects in the ecosystem use Cachix as their way of handling and publishing. Internally, you can also run things like Cachix and other things locally, internally. It's really simple. It's just essentially tarbles. You're serving tarbles. It's not even worth thinking about. But that means if I want to raise a pull request and get someone in the sec team to review my security patch to Vim, which removed this compilation flag, this one right here, they wouldn't have to wait like this for the compilation. Matter of fact, this compilation could actually be done out to a distributed build system. Nix supports distributed build systems, so you've got what's called Hydra Nix. So Hydra is a CI/CD system, but there's also systems what's called Nix Builder. So you can actually define field hosts in the configuration of Nix. So if you've got a farm of machines, you'll actually farm out the expression out so you can build. All right, so here we are. We've got our custom version of Vim, and this has been patched. This has been patched. Very special version of Vim. And if I type Vim again, it is going to not recompile because this is the version it's coming from patch. But this is all built from source. I need to reticulate. This is all built from source. So if I re-enable this and type Vim again, it's going to evaluate the original expression, which is the pinned version, and it's going to be instant. But if I remove that and then I go there, which is my security patch, it's also instant evaluation. I guess that's it. Like, a lot of cool stuff can happen if you go back to fundamentals and you work with good primitives. That's it. You got any questions? Ask me anytime. I'm going to go have my coffee. Thanks for tuning in.